For billions of years, our sun has been the unwavering heart of our solar system, a colossal furnace of light and life. It is the source of all energy, the anchor of our world, and the very reason for our existence. Yet even this cosmic titan is not eternal. Its brilliance, its warmth, its very being are all part of a finite, magnificent cycle. The sun, like all stars, is destined for change, for transformation on a scale almost beyond human comprehension. Over the next 10 billion years, our familiar star will undergo a series of dramatic metamorphoses. This is the story of its inevitable evolution. This is the epic tale of our sun's life, death, and cosmic aftermath. Today, our sun shines as a vibrant, middle-aged star, approximately 4.6 billion years into its life. It is a main sequence star, a classification that speaks to its current stable phase. This is the prime of its stellar life. At its core, the sun is a colossal sphere, composed predominantly of hydrogen and helium. These elements are the fundamental building blocks of its immense power. Its sheer mass creates an incredible gravitational force. Deep within its heart, under unimaginable pressure and temperature, nuclear fusion continuously takes place. Here, hydrogen atoms are relentlessly crushed together, forging helium and releasing vast amounts of energy. This process is the engine of our star. This fusion energy creates an outward pressure that perfectly counteracts the inward pull of gravity. This delicate yet powerful balance defines the sun's main sequence stability, allowing it to shine steadily for eons. The sun's current stability, however, is not destined to last forever. Subtle changes are already underway, setting the stage for its grand transformation. These initial shifts will unfold over billions of years. Approximately 1 billion years from now, the sun will begin to brighten noticeably. This gradual increase in luminosity will slowly but surely raise Earth's surface temperature, initiating profound environmental shifts. Our planet will become increasingly inhospitable. In about 3 to 5 billion years, the hydrogen fuel in the sun's core will begin to dwindle significantly. The primary fuel source for its fusion engine will be exhausted, marking a critical turning point in its life. This depletion is the first sign of its impending demise. With less hydrogen to fuse, the outward pressure from fusion will weaken. Gravity will then gain the upper hand, causing the sun's core to slowly but inexorably contract. This contraction will generate immense heat. Paradoxically, this core contraction will cause the sun's outer layers to begin expanding dramatically. The increased heat from the contracting core will push these outer regions outward, initiating a colossal swelling. This marks the end of its long, stable main sequence phase. The sun's expansion will accelerate, transforming it into a colossal red giant star. It will swell to hundreds of times its current diameter, becoming an immense, luminous sphere of cooler, diffuse gas. This will be a truly awe-inspiring yet terrifying sight. As the sun expands, its outer layers will reach far beyond its current boundaries. The innermost planets, Mercury and Venus, will be inexorably engulfed and vaporized by the sun's fiery embrace. Their existence will cease. Earth, too, will face a fiery and inevitable end. The sun's expanding outer atmosphere will eventually reach our planet, vaporizing its oceans and atmosphere. The very rock of Earth will be consumed, leaving no trace. The inner solar system will be utterly transformed. Once vibrant and teeming with life, it will become a desolate, superheated expanse, dominated by the monstrous red giant sun. All familiar landmarks will be gone. Despite its immense expansion, the sun's core continues to contract and heat up. Eventually, the temperature and pressure will become so extreme that a new fusion process ignites. This is the ignition of helium fusion. In this new phase, helium atoms in the core will fuse together, forming heavier elements like carbon and oxygen. This process releases a new burst of energy, temporarily stabilizing the sun once more. It is a brief reprieve. However, this helium-burning stage is relatively short-lived compared to the main sequence. The sun will burn through its helium fuel much faster, leading to further instability and dramatic changes. This phase is a fleeting moment in its long history. As the helium fuel depletes, the sun will become increasingly unstable. It will begin to shed its outer layers into space through powerful stellar winds and pulsations. These expelled gases will drift away from the dying star. These expelled gases and dust will form a spectacular glowing cosmic structure known as a planetary nebula. Illuminated by the hot, exposed core, these nebulae are among the most beautiful and intricate objects in the universe. They are the sun's final, breathtaking display. What remains after the planetary nebula disperses is the sun's incredibly dense, hot core. This remnant is known as a white dwarf, a stellar corpse composed primarily of carbon and oxygen. It is roughly the size of Earth, yet contains the mass of the sun. The white dwarf no longer generates energy through fusion. Instead, it slowly radiates away its residual heat, cooling and dimming over unimaginable stretches of time. It is a dying ember, gradually fading into the cosmic night. The sun's 10 billion-year journey from birth to black dwarf is a profound reminder of the cosmic scale of time. Our entire human history, our civilizations, our very existence are but a fleeting blink in the vast lifespan of a star. It is a humbling perspective. Our brief existence is intimately intertwined with the life cycle of our star. We are children of the sun, dependent on its stable phase for our very being. Its future is our ultimate past. Yet, there is immense beauty and wonder in this stellar evolution. The dramatic transformations, the creation of new elements, the formation of nebulae, all speak to the dynamic and ever-changing nature of the cosmos. It is a universe of constant renewal. The sun's enduring legacy extends far beyond its eventual demise. The heavier elements forged within its core and those expelled into space will seed new generations of stars and planets. Its material will become the building blocks for future cosmic structures. In this grand cosmic dance, we are connected to the universe in the most fundamental way. The atoms within us, the elements that form our world, were once forged in the hearts of stars, including our own sun. Its story is, in a profound sense, our story too.